Thank you all for being here this afternoon. This marks our 6th lecture during the academic spring semester 2021. Lectures were divided among 2 classes I'm teaching at Morgan State University School of Architecture and Planning into Just City and Circular Economy in Construction Material. Today, both students and non-students, our guests, welcome, have been invited to learn more about materials and their lifespan. We hope this will open up a nice discussion and give you the opportunity to look at construction and built environment under a new lens. Francesco just informed me that he is welcoming questions during his lecture to make the lecture more interactive. So whether you want to verbalize your question, you just unmute yourself, or you want to type your question, both are fine. I will monitor both. We hope that, please note that this lecture is being recorded and it will be shared on the Baltimore-Rotterdam Committee YouTube channel. Please also note that we have reserved some time after this lecture for questions and answers. The same questions can be typed into the chat windows. And again, I'll be monitoring that and ask questions directly to Francesco if you don't feel like verbalizing them. Finally, I would like to thank the Baltimore-Rotterdam Sister City Committee for energetically and patiently supporting all these lectures. And now, about our lecture this afternoon and evening. Dr. Francesco Di Maio is currently the Researcher Director of Recycling Laboratory at the TU Delft in the Netherlands. Francesco holds a Master of Science in Chemical Engineering and a PhD in Environmental Technical Physics. In 2015, he received a MBA, Master of Business Administration, from the Rotterdam School of Management. He's involved in projects on waste separation, recycling, resources efficiency, and circular economy. The main target is to develop effective and economically feasible technologies and methodologies that produce high-quality raw materials from EOL, end-of-life products. At this point, I'll kindly please put your mic on mute if you have not done so already. Put yourself on non-camera because this is recorded, so if you don't want to be captured by it. And with the exception of Francesco, of course. Francesco, please take the floor and thank you for being here.
Thank you very much, Cristina. Good afternoon, everyone. I really thank you, Cristina, for inviting me to give this lecture to your students, to the other people interested in this topic. It's pity that because of the COVID-19, I cannot be there as I was a few years ago. I hope in the near future that we can start again traveling, and then I will be happy to come to Baltimore in person. So today, I would like to talk about recycling technology for the recycling economy. Because we are at the group I belong to, the group of resources recycling at the Delft University of Technology, and we are indeed focusing on making technologies which can really close the loop, the material loop, and implement the circular economy in the construction sector. And I will show you how we do about that. So first of all, I would like to say a few words about the motivation. The motivation of such work is because building materials is really leads to a massive global resource extraction, and concrete account for the main share. The technology we have been developing so far focus on concrete because concrete is one of the main building material, and because we feel that there is more potential there. And the cement industry contributed to 5% of the global CO2 emission. And this is also one of the motivation we want to recycle concrete, because then we can also get back the cement, which is used to make concrete. And just to give you an example, the steel industry contributed also to 5%. Then to give an idea of what is the massive amount of CO2 which is involved in such industry. And another point I want to mention that is 88% of all aggregate produced are from natural resources. And then it is really necessary to find the other way to get the aggregate we need to produce concrete, which is, again, it's the main construction material. And still, I want also to mention that the construction demolition waste increase exponentially because the buildings are reaching the end of life, then are being demolished, and then we have a lot of the materials which need to deal with in one way or the other. And land filling is not an option anymore. I mean, in many countries, it's not an option, and we will see that as mentioned also in below, you see that if all the demolition waste produced in Europe would be landfilled, it would occupy an area of 75% of Dutch land. And you can imagine that it is quite big. Even Netherlands is not a huge country, but still 75% is quite a lot. And also one more motivation is that in the European Commission set a very ambitious target on the construction, on the recycling of the construction material. And by 2020, that must be, actually it is now, and it is indeed, it is being done, 70% by weight should be recycled. So now these slides, maybe you know these slides because it has been made by Cristina, and here is what this slide is helping me to tell you that indeed in the city there is a lot of materials which can be valorized and used to make new buildings instead of downcycling or even worse, landfilling. So it is possible to replace the current linear make dispose industrial model with the more profitable and environmental friendly circular economy one. Yes, I mean the answer to this question is, to my opinion, is yes, it is possible, and that there are ways to do that, and to help me to do this, to explain and to into more details what I sorry, what I feel it. I will go to explain you to focus. I would like you to focus on a cubic meter of the materials which is moving into the truck, which is delivering the concrete. Then you see that this cubic meter contains a value of about 90 euro. 1 cubic meter of, by the way, 1 cubic meter of the concrete is about 2.5 tons of the material. So this cubic meter of the material, when it is embedded in the building, we can assume that it is still value 90 euro, even though it is the value will be higher because it is a part of the building, then the value would be higher, but let's keep 90 euro. When this material when the building is demolished, then what is the value of this material, of this cubic meter? It is normally, it is between 12 and 15 euro because it contains not only the concrete, the crushed concrete, but it contains also the pollutants like bricks, glass, gypsum, and so on. That sometimes it contains even asbestos. And in this case, of course, the value is very much negative, not even 12 or 15, but much negative because asbestos is a very dangerous material. Then this is, but even though, I mean, the value is going from 90 to 12, 15, this materials is still recycled because it is used most of the time as a road-based materials to make a new road. But as you can see, even graphically, this is not a circular process because you go from materials which value 90 euro to materials which value 12, 15 euro. And this means that you still need to dig and to produce new aggregates to make new concrete. Then it is not circular. What do you need to do to make it circular? Then you need technologies for sure. You need the technology to be able to separate the bricks, glass, gypsum from the crushed concrete and then make it pure concrete. Then technology is definitely a must, but it is not enough at all. You need also new business models, you need the organization, you need the monitoring. And then we will go about this. because these are really, all of them are key point to make that cubic meter of materials, which value 12, 15 when it is crushed, again back to 90 euro. So the technology must be cheap, because the value anyway it is not very high. Then you cannot spend 50 euro to get materials which value 20 euro per ton, or even less actually. Then that must be cheap. And then if the process must be cheap, it means that they must be very clever technologies. There should be no residues, because again, landfilling is not an option, because otherwise it will make the whole economic process negative, and then it will not be implemented by industry. And the quality of the materials has to be a good material, because constructors are not going to jeopardize their project by using materials which can affect the structure of their building, and then they are responsible for that, and this would make their company into trouble. Then the quality must be high quality in order to make a high quality product. Business model, they are also very important, because again, the target is here to reduce cost and to increase the trust. And in order to do this, one solution is to avoid and minimize transfer of ownership, to avoid that the materials go from one actor to another actor, and each actor wanted to gain some profit, and this means that eventually, again, the full process is not economically profitable. Then we need also to transport for economic reason, but also for environmental reason. And then we need to create transparency about quality. People must know what they are buying, because if they are not clear about what they are buying, they don't buy it. And if they don't buy it, it means that there is no demand. If there is no demand, the value of the recycled materials is almost zero. And then again, you don't close the loop. And then still we need to dig new raw materials, virgin materials, to build a new building, construction, infrastructure, and so on. So this is in a nutshell what we are doing, what we have been doing, what we are doing, and we will do in the future to make this happening. From the end of life buildings, we go to the smart dismantling, which means that we deconstruct the building in a smart way. I will show you later how it is done. Then we have the selected demolition to get only the concrete, only the clean concrete, as clean as possible. Then this clean concrete is being crushed in a crusher. Normally, this is nothing special. There is a state-of-the-art technology. And then we have, if it is necessary, we have the sensor-based sorting to remove a big pollutant from the crushed concrete. Then we go to the IDR, which is the acronym of Advanced Dry Recovery, which is a patented technology developed in our group, in the group of resource and recycling, which can produce clean aggregate for 16 millimeter aggregate, which is very clean and can be used to make new concrete, but also 0.4 millimeter sand, which goes to another technology also patented by our group, which produces minerals and recycled sand, clean sand. So now I will show you some pictures, because pictures are much better than such a graph. And here you can see how to do the selective, the smart demolition, or selective demolition, it's the same. Then we just, in this case, actually it was a project really done in Groningen a few years ago, but I mean, this is, we have been doing also later on, but I like this photo, that's why I'm using this photo. Then you get all concrete, the building. It was tower of 40 stores. For Netherlands, for Europe, it's a high building. Probably for US, it's not that tall, but still here it's tall. And then you see a bobcat inside the building to remove the gypsum, the metals, the carpet, the steel. This also you see a guy who is dismantling the hydronics of the building to separate valuable materials like copper and so on. And also you get valuable materials, but also you get eventually clean concrete to be crushed. And here you see the carpet that they are collected, and they are selectively placed in different containers. So then we go from the buildings you see on the left to the building you see on the right. And the materials to use it is the one the heap you see in the front of this picture. This is now exactly the crushed concrete we use as an input of our technologies, which we call C2CA technology, which stands for concrete to cement and aggregates. I want also to, actually, I'm proud to mention that this, we set up a spin-off company of the Technical University Delft, which names exactly C2CA technology. And this technology has been getting quite some interest from international organizations because they found that it is a useful, a very important, useful technology to make construction circular. So then we go from the, you see the end-of-life building, we concentrate on the end-of-life concrete. And then with the smart demolition, we get clean concrete. From the clean concrete, we with the crushing, we get the contaminant, the steel rebar, the crushed mineral. And then by using the C2CA technology, we obtain the aggregate measure bigger than 16 millimeter, the 416 aggregate, the 04 sand, and the cement paste. And this is used to make new concrete. And then we make circular. So, and now, first of all, I would like to know whether you have a question, a comment, anything you wanted to say now. I'm always, you can always interrupt. If not, I go ahead, and then I would like, this is the working principle of the advanced dry recovery technology. Then you see here the input, it is a crushed 0.16 millimeter crushed concrete, which comes from the crushing of the end of life concrete. But it is sieved, and we get the 0.16 millimeter. The 0.16 millimeter is fed into the IDR. The IDR basically is an advanced sieving machine, which has the very interesting capability of sieving materials which are wet. And since during a demolition project, you always spray water to reduce the dust, and also because in Netherlands it's raining quite often, then anyway you will get wet material. As you may know, you cannot sieve wet materials with the conventional sieve because the sieve gets trouble, that gets stopped. Then the IDR is making a very fast jet. It's creating a jet of materials. It's accelerating the materials at about 3000 G. Then by doing this, and with the cleverly place the compartment, the machine, we separate the heavy particle from the small particle. Basically, it is as when you go to the sea and you get a hand of materials from the sand, and then you throw it against the wind, you see that the heaviest particle fell more farther than the fine particle. And this makes possible to produce on the right side clean aggregate, and on the left side you get the 0.1 millimeter plus the 1.4 millimeter fraction, which contains more contaminant, pollutant, that these are going to another patented technology, which is called the heating hierarchy classification system. Now I would like, first of all, I wanted to show that the machine I'm talking, the technology we are talking, it is not in the hand of the gods, but it is really, it is implemented at industrial scale, and we even made it movable, because we wanted to have the possibility, whenever it is possible, to bring the recycling facility to the demolition site instead of bringing the materials to the recycling site, whenever it is possible. Then the IDR is movable. And here you see a more detailed picture of the feed and the product. You see what are the feed. It is a bit dirty, and also the silica part are stick with each other, while you see on the right side, the material is much more clean. But still, on the bottom right side, you see that the fine contains some small wood. For instance, this one is a small piece of wood, for instance. And probably this is also a small pollutant. So this is still the IDR. And now I will show you the heating hierarchy classification system to treat the 0.4 millimeter fraction. This is the working principle of this machine. It is a kind of it is a sort of fluidized bed reactor, but it is not. But it is similar. And then from the top we feed the material, and then there is a heating zone where the materials the sand get kind of separated. They get separated from the cement paste, which sticks to the silica part. Then the fines are, because of the flow, the fines are going to the left side of this. In this graph, it is on the left side, you see the cyclone, where the ultrafine particles are separated, and which the ultrafine particles are the one which are shown in the bottom right picture of this slide. In the middle, you see the clean 1.4 millimeter fraction, and on the top, the feed. And this also the HAS is also movable. And then this picture show one demonstration, we have done. Actually, we are doing many of these, but also because the machine is working. Then we are processing materials, and here you see the IDR and the HAS working together. And this graph shows that the calcium content of the fine fraction of the HAS contains quite some limestone, like some CaCO3, which is the main component of the limestone, which is the main feed of the cement kiln, which means that it can be used as raw materials for cement production. But there are also other use. I mean, I cannot go too much because my time is limited. Otherwise, Cristina gets nervous to me. So, and here you see the quality of the materials that we are producing. You see from the graph on the top show the performance, the compressive strength of the coarse aggregate produced by the IDR, and it show mechanical properties even better than the one of the natural aggregate. And another important aspect I mentioned before, it is the monitoring, and this is a very important aspect which we are focusing on right now, because we want really to make people confident of the materials they are buying. And in order to make this, we need to assess the quality of the materials, not by sending the material to the lab, because then you need days, you have to wait days to get the analysis back, and this is not possible. We need to have an assessment of the quality of the materials right away, right now, in the moment we are processing the material. And to do this, we are using laser-induced breakdown spectroscopy and with some RFID tags to make which will make all the value of all the process, all the steps in the value chain more clear. This is the LIBS. How does the LIBS system work? There is the laser produce a plasma when it hits the materials, and the plasma, when the plasma cool down, then you get the spectral response of the materials which are made plasma. I mean, when the laser produce a flame, then when again the flame cools, it emits some photons which are collected by the spectrometer, and by the analysis of the spectra, we can get an idea of the pollutants, of the composition and the pollutant, if any, which are moving in the conveyor belt. Now, we are transferring this information in a tracer, in a RFID tracer, and then we are now conveying this information next into the materials which is going to the market. Then the materials is not only of a high quality, but the quality of the materials is assessed by the LIBS, and this information is transferred through the RFID to the customer, who will be able to check whether the materials he or she bought is the one which he or she is waiting for. And this is a very important step, because it will reduce the main, to my opinion, the main bottlenecks which prevent the use of recycled materials, which is the lack of trust. In this way, we can increase the trust, and then we are confident that this will make a difference. And this is, here you see the RFID reader and writer. And then we have made a lot of tests. Of course, we have here on the right side, you see an RFID in blocks of concrete. We have checked all the durability and the readability, all of this process. Of course, I cannot go showing all these results, but I wanted to say that also we have we made a demonstration in the field. And then here you can see a picture of the materials we are producing. And as you can see, the materials is quite clean. Then it has high quality. And then it is not only it is clean and high quality, but this quality can be, the information about the quality can be transferred in the following step. And then it can increase the marketability of this material. So, and now I would like to tell you what are the economic driver which makes this technology interesting, this spin-off company interesting. And actually, basically, it is similar to what I said before, but I want to just, this is more tailored for the company. The aggregate sector is the largest among the non-energy extractive industries. The European aggregate demand is quite big. It's 2.7 billion tons per year, and they also represent a big amount of turnover. The global construction aggregate market is growing quite fast, and in the US it went from 560 billion and it will go to 560 billion by 2024, and it is growing at 6.1%. This is a forecast. But then you think there is also market potential for the company and in this sector. And again, the 88% of aggregate producers are from natural resources. Then it is also a motivation for environmental motivation. And the remaining is come from recycling. Then you see there is only 80% come from recycling, which means that there is a very big potential for recycling industry producing high quality material. And the company who are also able to transfer the information about high quality material. Okay, yeah, maybe I go a little bit faster because otherwise the time is going to be a problem. And here I want to mention that the data, some raw data about the plant for this machine, for an industrial machine. And you see the operational cost is not very high, which means that there is potential really to make business, to make money out of this. And if as soon as many Dutch people say, let the market do the job, and this is really the way to do to implement circularity. It has to be the market. It has to be market driven. And this I would like to show these slides because it makes me. I was happy when I made this calculation because I can see that we can indeed make circular, the end of life, the concrete circular. On the top table, you see what is the composition here of 1 ton of the concrete. What is the value per ton, and what is the value in 1 ton of the concrete? In 1 ton, not 1 cubic meter. What I talked before was a cubic meter. Now it is 1 ton. And then you see that the value is about 20 euro. And then on the bottom table, you see what C2C technology can do, to what extent it can make to circular. And we can recover 12 euro of this 20 euro, which means that we can our technology is 60% circular, we can say, if you like. And this is already quite big achievement. And also in this picture, I want to show again to repeat to make it even more clear. From the building, you see that there is the crushing. You make the rubble on the left. Then we use the IDR. The IDR produce the clean aggregates here, and then it is 60%. The 40% goes to the HAS here. The HAS produce 10% of hydrated cement of the minerals and 30% of the sand. And as you can see even from the picture, the materials is quite clean and it is useful to make new construction material. And from the environmental issue, I want to emphasize that by reusing recycled cement, we are saving the CO2 which is released when you feed limestone in a kiln for cement production. To make cement, you need the limestone. When you put limestone in the kiln, it is decarbonized, and the CO2 is produced even not because of energy consumption, but also just because the chemistry of the reaction goes from the CaCO3 to CaO, which is what the cement need, and the CO2 is released. That is it's not possible to avoid this. But if we feed the kiln with the CaO, of course, there is this CO2 is saved. And this means that we have also quite potential benefit, quite positive effect on the environment. So the innovation, where is the innovation? Technology, as I said, technology is very important. You must produce high quality materials, but also you need the business model, and you need, especially, I wanted to emphasize create transparency about quality, because people will not buy materials if they are not sure about what they are buying. This does not mean that the materials has to be of the highest quality, but because people may be also interested in materials which are not of the highest quality. If they need the materials to produce bricks, for instance, they don't need to buy virgin aggregate to produce bricks. They can definitely buy recycled materials of low quality, but they need to know what is the quality. It cannot be just I buy. What is the quality of the material? It's a low quality, okay, but you cannot stand. You cannot give a price to these materials, and then there is no market. There is no market. There is no demand. Again, there is no possibility to make a circular, to make a circular construction circular. Thank you very much. This was my last slides, and I'm very happy if you have a question. I'd like to, or discussion or opinion, to share with me, please.
Thank you very much, Francesco.
Thank you, Cristina.
It has changed since last time I listened to it. Wait, I think there are some, it has changed in meaning the world is being more open. There is a question. Hélène, do you want me to read it or do you want to state it yourself?
No, I'm happy to ask it myself.
Please
so
do.
I'm really impressed how well this can work for a large building where the percentage of concrete is pretty high, but how does it work when you get smaller units or row homes where there's much more brick and wood and those materials? Can you do something there?
No. When there is bricks or other materials, as I said, the concrete account for 60% of the concrete in construction demolition waste. And then if we are even able to deal with the 60% of the construction demolition waste, we already would make a big difference. In the US, I found a report of the Environmental Protection Agency, which says that the concrete account for 60–80% of the construction demolition waste. And then it is even higher than what we have in Europe. When you have bricks, but the bricks are a minor. It's a minor construction materials. It is not the largest buildings are not made by bricks. Are made by only the old buildings are made by bricks. And when you have bricks, then actually I'm involved in another project where bricks. The people try to recycle bricks, and the solution is that you need to get the bricks as they are. I mean, don't try not to spoil the bricks, because the only way to recycle bricks is to take the bricks, don't break them,
reuse them,
and reuse them, because it is impossible, or at least actually it is possible, but it is not economically feasible to recycle bricks industrially. So far, there are no way, to my knowledge, to make this bricks industrially. And then the other construction materials is the wood. The wood you can, there is a way to recycle wood. There is a glass, and there is a way to recycle glass. Steel is not a problem. Steel is being recycled with completely no problem at all. The main issue is concrete.
Well, thank you very much. Hélène, are you satisfied with the answer?
Yes, I certainly. Thank you very much.
Now we can talk more if you wish.
There's a question in the chat from Klaus. Klaus, do you want to verbalize it, or should I read it for you?
Well, I can speak to it. You mentioned the reduction of CO2 that comes from the different chemical process if you use the aggregates from recycled concrete versus lime, but I did not see from that how much of the total CO2 output that is in concrete making, and how much of even in the recycling process, how much CO2 remains, because the kiln itself is a big energy eater.
Yeah, this is you mean this?
Yeah, what's the difference in percent through this process relative to the traditional process? Yes, right, that slide.
Okay, but I mean, this depends on. I mean, when in the process of recycling the end of life concrete, we get 10% is hydrated cement. Here, these materials can be used as raw materials for kiln. If you feed the 1 ton of this material in the kiln will not emit this CO2 here. And then, I mean, it is basically you save about 50% of the CO2 emitted to produce 1 ton of cement. Because roughly, to make 1 ton of cement, you emit 1 ton of CO2 because of the energy, and 1 ton of CO2 because of the chemistry. The ton of the CO2 that is connected to the energy, you still have it. I mean, it is still there, but the ton of the CO2 which is related to the chemistry is not there. Is it?
Yeah, that answers the question, because in the beginning of your presentation, you showed how much global CO2 emission comes from concrete production. And so that gives us now a sense of how much reduction that will be. So about half.
Yeah. We cannot produce all raw materials for the.
No, right. I see.
So you're essentially proposing to refire existing cement.
Yeah. It is I mean, it is a raw material. So it is just it contains CaO, and then it can be used to make the raw meal in the kiln.
Gotcha. And does that affect the overall strength of the material once it's used in construction?
Sorry, I don't get. I mean, the cement is again you get again cement. Then you get new cement. Then there is no difference.
Oh, there's no difference. Oh, that's fantastic. Well, I kind of wanted to ask a question. So thanks so much for the talk. I really, really appreciate it. My research is a lot about kind of using building materials from the site and trying to upcycle things as much as possible. Using the site as material very much. I'm pursuing a patent on a tire roofing system, but I really appreciate concrete and really like to use concrete as a way to kind of trace the site. So yeah, I found your talk completely fascinating. But I'm really close to my structural engineer as well, and we have conversations about upcycling materials very often. Most of the time about wood, and just the kind of certifications that would be required. And in terms of a lot of this work, I guess that was one of my questions. You mentioned that a big hurdle is kind of opening up the quality and really showing the way that that's the same. Has there been any certifications that have been gained from testing agencies in the U.S. here? We'd have the ACI, the American Concrete Institute, but I don't know if the equivalent of that in Europe is.
There is equivalent of that in Europe, but this is a very important issue. Of course, it should be the next step. So far, there is no certification. But we are in one of the projects we are involved. There is also a partner who is involved in certification issues, and they just last week they told me that they are trying to push this the certification issue into the committee. But I understood that it is a quite long procedure. It's not something that it will be quick. But on the other hand, I must say that in Netherlands, the construction industry made an agreement that they will be using a minimum of 5% of recycled materials into new construction. And this is a good way to make the recycling industry more confident to invest into technology and to produce high quality material. But you are absolutely right. The standardization will have to be there. And one of the things we are working on now is to check the quality and to convert this quality into a kind of recipe to make a better use of the materials. Because again, as I said before, I think we don't need to make, if we wanted to build a bench for the park, we don't need to use the highest quality materials. We can use a more reasonable low material, because it is not going to get into mechanical stresses. And I think that we have to also go to make a relation between the quality and the use, and then also the standardization. It will be there. But I think at this moment we are just starting to make these materials, and it will have to take some time, I guess, to go through the process.
Yeah, exactly. That's a really good point. There's different strengths that are required across building materials. I mean, you don't need the highest quality stuff to make a bench, but you probably would to make a bridge. So is that a way that you and your team is kind of trying to push this forward, is to try to get different levels of quality achieved first? So that, gotcha. Okay, yeah, that's fantastic.
Yeah, to make better use, because then I found it very, very not logical that people buy virgin materials to make bricks for the paveway. No need. Yeah, you can buy a lower quality, and it's completely fine. But in your case, you are reusing. I understood. In your case, you reuse the material
as much as possible. Yeah.
The component level.
As much as possible. Yeah.
On the question of the overall impact of the reduction of new virgin concrete, you quoted EPA as saying that their recycling volume here, or construction debris volume out of concrete, is even higher than in Europe. As an architect who practiced on both sides of the Atlantic, I find that a little hard to believe, because there's so much more concrete construction in Europe than in the US. I mean, the entire low-rise multifamily and single-family market here doesn't use any concrete except for floor slabs. And a lot of the high-rise or commercial construction here is steel, depending on what region in the country one is. So I wondered whether that information from EPA was correct. I think there is a lower market here in terms of concrete. And I wondered, as a question, I mean, one of the big discussions on both sides of the Atlantic is the use of wood in commercial and higher rise construction to replace concrete because of the better CO2 balance. And what do you think about that?
Concerning the share, the report of the EPA was from 2018. And then in this report is written that in the US, 68% of construction demolition waste is concrete. And I think that in the US, also the highways are made in concrete. And this makes quite make the use of the concrete quite a lot. Probably it is not in the buildings, but in the highways, it's quite a lot. Continue for the wood. I mean, we are not focusing on the wood. Wood is by definition a circular materials, no, of course. But the use there in Netherlands, at least, I think that probably 100%, or if it is not 100%, closer to 100% of the wood in construction goes to incineration. There is no other. We are involved in a project where a Finnish partner is working on wood, and then they are using the demolition wood to make like yeah, they even use extruders to make like tables or I don't know, that's things that you walk closer to the harbor. How to call this stuff? Where the one on the lake, for instance, you have that pathway which
dock.
goes. Huh?
Dock.
Yeah. Yes. Yeah. They make dock for, and then yeah. That is what I heard about. In Finland, they are quite good at because they have a lot of wood in the construction. But in Netherlands, it goes to incineration.
I think Chris has a question.
Yeah, sure. I was no, I think this is such a wonderful topic. I grew up in a recycling family and putting all my cardboard away and my aluminum, and then the first time I went on a job site and I saw all of the waste in the dumpster and everything, I was horrified. So this is such a wonderful thing to be focused on. I was going to ask about if this was commercially available yet, or if you're still studying it, but it sounds like it's still in study. I'm wondering if it's the companies that produce aggregate, are they interested in investing in this, or are they threatened by it and perhaps trying to, you know, make you look bad or fight you?
No, the company is already. I mean, it is exploiting industrially the technology because the IDR and the HAS are at industrial level. The IDR is producing, it is processing 100 120 tons per hour of material. Then it is quite industrial. The HAS now at this very moment it is 3 tons per hour, but we are making a 10 ton per hour machine. Then I think it is yeah, it is on industrial. We are now what is still to be make full industrial is the monitoring system. We have it in the a pilot machine in our in the lab, and now we need to scale it up at industrial level. But all the technology is ready. It is that's why we are getting interest from industry, that they wanted the industry who wanted to really make their process more circular. Basically, you don't have much way to do it. I mean, you because for the steel, as I said, the steel, you know, it is being recycled, no problem. And then what comes next? Okay, you have wood, but wood is also a minor component. A minor at the global scale, it is a minor component. And what is the wood? Even it is burned, it is always. Anyway, you need the energy, and it is a biofuel. Then it is also reasonable to use as a fuel. And then the main component is concrete. And once we are able to make concrete circular, I mean, concrete is the main construction. Actually, no, it is a sand. Sand and aggregate are the worldwide most used materials after water. which means that it is really a big amount. And many people, many countries are now facing trouble with the sand. We feel that sand is a material. Oh, it's sand. It's nothing. It's sand is a precious materials, and it is not. There is not so much sand anymore. Many people think that, oh, there is a desert. You can use the sand, but the sand in the desert you cannot use it for construction. It is impossible. It does not have the correct particle size distribution. And there are countries where they are fighting for the sand. Actually, to be honest, I didn't know. I read two scientific articles recently. It is really, there are people, there are countries fighting for the sand. Then and there are environmental reasons out there, because there are in some countries they are digging mountains to get rocks and then crush it to make aggregate, to make sand. It is not environmental friendly for many reasons.
Thank you, Chris and Francesco. Sagar has a question for you. Sagar, please go ahead.
Probably is mute.
Yeah, he's mute. Oh, here he goes. Hi.
Hi, thank you, Dr. Francesco, for the talk. It was very knowledgeable. But I just want to ask you that, you know, the ratio of demolition of a building and the new constructions that's been going on, and is there a system placed where, you know, the two industries are connecting to each other, like a demolition industry and a new construction industry, so that they can talk to each other? You know, like if a demolition, they're doing demolition, new construction can come and talk to each other, and they can, you know, figure out what materials they could use from the building. Is there a system set up like that where two industries can talk to each other? So there is a, you know, there's no need of a middle.
Yeah, that's why
mechanism. Yep.
Yeah. That's why I said the business model should be also innovative, and in what we are doing here is that we think that a good solution is to make the company who make demolition to be partner of the company who is building the new construction. The best would be that they are the same, and because then you have the company who demolish the buildings. The company will take more attention in the selected demolition. They will make more attention in not polluting the concrete. And then it will, if you have a cleaner concrete, you produce cleaner aggregate, and then you can make better concrete again back from the recycled aggregate. And then, and then you make a better system. I mean, if you don't have, if this is not possible, then we wanted to create transparency about the quality by using the LIBS and the tags, to avoid that people along the value chain can be reluctant in using recycled aggregate, because they don't know what is the quality of the materials that they are buying. But one solution, of course, is to avoid the many transfer of ownership. And for this, you need the construction company to join the recycler, and the demolisher, and the concrete producer. Sometimes it happens that the same company is making the demolition, and then is making the new building. That is the best situation, because then they own the materials. The people who are making the new building owns the materials of all the building or construction being demolished, and then it will make the process smooth. I don't know if I answered your question.
Oh, thank you. Yeah, thank you, Doctor.
Hi, Francesco. There is a question from Fernando. He's asking, he's joining us from Colombia. He's asking if this type of process, circular economy, can be applied in third world countries. Out of your knowledge, if you know of it and if you have examples.
No, actually, we have been contacted in the past from less developed countries, and we are in contact also with the companies from South America. I mean, there are no restrictions. There are definitely no restriction of being used. Can be used everywhere, because it is economically feasible. Then, if it is economically feasible, it's economically feasible everywhere. Yes, I must say that in the Western countries, where the landfilling is an issue, it makes the process more more convenient, because if you can landfill materials for zero, then the incentive to invest resources in making new materials out of recycled of end of life materials is lower, because you can just dig in a hole somewhere and trash the materials there, and then again it makes less attractive the recycling route. But if in a company in any country would have a kind of landfill ban, or if a less developed country would enforce some like high fee for landfilling materials which has the potential to be recycled, as it happened in the Netherlands, for instance, then it would immediately makes the situation more attractive. As you know, in Netherlands, if you landfill materials which has the potential to be recycled, then you pay a lot of money.
Yeah.
And this is the process more. People don't want to spend the money to landfill. Then they say, okay, if I have to spend the money to landfill, then I prefer to invest in technology and make and minimize the amount of material to be landfilled.
Yeah, it makes much sense. So I do have some questions for you too, and it might be a recap, and it might be something that you already told me, but I think it's important to put a point in this. So I think that during your conversation, you said that our economy is 20% circular already. Did you say 20% or 80%?
No, I didn't. I think I didn't. Where did I say this?
I thought I heard our economy is already 20% circular. So
no. I here probably here I said no. In this, when in the table here. Ooh. Here.
Yes, exactly. What did you say?
No, here I said that our technology can make can extract 60% of the value which is embedded in 1 ton of concrete.
And this, are you talking about the Netherlands, Europe, the world? It doesn't matter.
No. I'm talking about our technology, our C2C technology. Our C2C technology, which is made by the IDR plus the HAS plus the LIBS-RFID system, it can extract 60% of the original value of the concrete, which means that we can say that our technology can make is 60% circular.
Exactly. So very profitable. So did you tell us a little bit about the time implication to do this?
The time?
Time. How long does it take to conduct a circular a cycle?
No, it really takes really very little. I mean, it can be done in a matter of hours. I mean, if because we can the moment that we have the crushed concrete, we process the crushed concrete with the IDR at 100 tons per hour. Then the next there is the HAS which process the fines here. Then there's the building here. Then we crush the buildings and then we get the crushed concrete. From the crushed concrete goes to the IDR, and the 60% is already cleaned to make new concrete. The 60% here, this.
Yeah.
Then 40% goes to the HAS. The HAS produce sand and the fine, and then these materials plus this two, this plus this, can go to make new concrete for new construction.
So now we're talking about a very fast process, and we're talking about the necessity, obviously, to do it because we are short in resources, right? Is this a competitor to concrete manufacturers?
No. It's not. Actually, the concrete manufacturer can also be interested in buying, in applying this technology, because they are the concrete producer need to buy virgin aggregates to make concrete, and for instance, the precast concrete industry is very interested also because one of the advantages of recycled aggregates, it is that it set faster than virgin aggregates, because probably not, it is not sure, but probably because the recycled aggregates has already been in contact with the cement in the past. And then the surface of the recycled aggregate is more reactive than the virgin one. And we found that, where it is, we found that it set faster. The speed after 7 days, the compressive strength of recycled aggregate is higher than the compressive strength of a natural aggregate. Then later it reached the same, but for precast concrete industry, it is interesting because they would need less time to release, to make their plant, the installation free of producing new components. Then it has no any, let's say, economic enemies. I mean, and also considering that even we are recycling the all aggregates from demolition, then we still need of virgin aggregates, because at least because we cannot, the amount of a building we are making is larger than the amount of a building we are demolishing. Yeah. Then also from this point of view, there is no. Then I think it is everybody would be happy. Let's say the cement industry is happy because they would make less emission. Then they would pay less for the emission they are producing. The concrete people, for them, is completely, actually they could even have the benefit of using faster setting material. No, I don't see problem in this respect.
I see. So you do believe that there is less skepticism in upcycling concrete? Because I do remember that there was at the time when when we made that diagram, I remember that in the Netherlands, especially, concrete, upcycled concrete was used for roads or for acoustic walls in the highways, but not yet for building, because there was skepticism on the quality of the concrete. How do you say? How do you see this?
We see by using the LIBS and the monitoring system, we see that when you need to make new road, then you need the aggregates. then if you need to make new roads and there is a demolition site next to it, the best is to use the recycled aggregate to make new roads. Because anyway, you need the new aggregate to make road. Then the best solution is that one. But if you don't have a road construction nearby, and I mean nearby, I mean in the radius of 50 kilometers, because transporting concrete, it costs money by truck. Then if you don't have construction, road construction nearby, then I think using this technology to make new concrete is economically sound. But again, if you need to have, if you are still making a road, then use it as a road-based aggregate. But in Netherlands, the amount of roads to be made are decreasing because there are already a lot of roads here. And in Japan, there are a lot of roads already being made. In many developed countries, there are roads, but the logistics plays an important role. It depends where the demolition site is, where the construction site is, because transporting heavy materials it has a cost, and then
very interesting. So, well, my last question also, because we are almost at the end of our class, is, so do you think that the construction panorama will change? Like, for instance, there are still countries that are heavily relying on vernacular, like the adobe, right? The brick. Do you think that this will change in the future because of the difficulties of upcycling brick? Or do you think that things will, you know, the technology will catch up with that?
Sorry, Cristina, you see the brick?
Yeah, you were talking about brick, right? Earlier, that brick is, it's very difficult to upcycle, right?
Yeah.
So, but there are some countries that are still relying on adobe, like dirt, right?
Okay.
Do you think that the scenario will change, that we will go more for concrete?
But Cristina, I think this is related also on the manpower, because I think the countries in where the bricks are used as a main construction materials probably are the countries where manpower is cheaper than countries where more industrialized the countries. I think bricks will still be, people will still keep using bricks. Even at the house here, I can see from my window there is still bricks. They are still making bricks in the outer facade. In the structure is concrete. The floor are concrete, but the external part is bricks, because bricks are nicer. We cannot avoid that. I mean, it will. I don't see that bricks will. People will not use bricks in the future. But if I know, there is a company in Rotterdam. This company is making business by going to where there are demolition of bricks made houses. And he get the bricks, but he processes the bricks manually, one by one, and he get. But there is no. I don't see other way, because the bricks cannot be. You cannot crush bricks and make new bricks. No, this is impossible. Then there is, but. It is possible in countries where, or when people want to pay more for all the bricks, because I didn't know this, I learned recently, but all the bricks has a higher value than new bricks. There are people here, at least I know here in Netherlands, people pay more for old bricks coming from old houses, as people pay more for old wood coming from old houses. Such that nice beams, wooden made beams. Some people pay much more for that old beams than the new beams, because they like the old beams. I understand, but it is still some niche market. I see. It is not the largest. If you go to China, for instance,
Yeah.
I mean, that is it would account for a very, very small fraction of the construction material.
Yeah, understandable. Well, again, very enlightening. Every time I talk to you, I'm just flabbergasted by the knowledge that you're bringing around the table. So I would like you, I really would like to thank you for having done this. And I really hope we can meet in person again, Francesco.
Looking forward, Cristina. I will be very happy to come. You come here, or I come to Baltimore and have a nice chat with you, with your friend, with your students. And I'm really looking forward. I have a very good memory of last time I've been there.
We did too.
And I hope also we can make it. We can make something with the Rotterdam Baltimore Alliance.
Yeah.
I would be very happy.
We definitely look forward. Well, thank you for your time. Thank you, students and non-students.
Thank you. Thank you,
for
everyone.
being here. Thank you. Have a nice evening and afternoon.
Have a nice afternoon, you too.
Bye.
Bye.